I'm going to evaluate and simplify some logarithms. All right, using the definition of a log, I'm going to rewrite this as an exponent. So I'm trying to take log base 12 of 144 and figure out what is that equal to. So I want to know what that's equal to. As I rewrite this as an exponent, the base is what I'm taking to a power. All right, so 12 to what power is equal to 144. All right, on this, because I know that 12 squared is equal to 144, so then that means that 12 to what power is 12 squared? Well, that has to be 2. Let's try another one. So log base 64 of 8 is equal to what? All right, using the definition of logs, I can write this as 64 to what power is equal to 8. Well, let's see. If I take the square root of 64, that is equal to 8. And the square root is the same thing as 64 to the 1/2 power. Okay, so then as I'm trying to solve my problem here, 64 to what power is equal to 64 to the half? Well, that better be 1/2. Okay, and last one, log base 3. So 3 to what power is equal to 1/27th? All right, well, 1/27th is the same thing as 27th to the -1, and 27 is 3 cubed, so that to the -1. So we could think of 1/27th as 3 to the -3. All right, so then my question is 3 to what power is equal to 3 to the 1/3? Or sorry, 3 to the -3. Well, that better be -3. Okay, so we can just kind of work backwards from what's given and just rewrite that as some power of 3 of the base. There's some logarithms, some bases that are so common that they have kind of their own notation. So log base 10, we would just write that as log. And on your calculator, when you see that notation log, that actually is log base 10. And there's another one that is log base, this number e. And e is just is a number that's about 2.7, and so that's called the natural log, not the log that's natural. And it's a nice way of modeling a lot of growth that happens in nature, and so you'll see a lot of applications in that in the next math class. But log base e is natural log. So if I'm trying to simplify log of 100, what that really means is log base 10 of 100. All right, so we're trying to figure out what is that equal to. And here's our base is 10. So 10 to some power is equal to 100. Well, 100 is 10 squared. And so 10 to what power? That better be 2. Okay, let's look at this one. So log of 0.0001 is equal to something. All right, so the base here, even though it's not written, is 10. So 10 to what power is equal to 0.00, let's see, 1, 2, 3, 1. All right, so that is 1, 2, 3, 4. All right, so 0.0001 is 1,000th. And that is the same thing as 10 to the -3. All right, so what's the exponent there? It is -3. All right, let's try this with natural log. So what natural log really means is log base e, okay, and then we're taking log base e of e to the -3, and that's supposed to equal something. All right, here's our base is e. So e to some power is equal to e to the negative 3? Well, we can see that the exponent is negative 3. Okay, so our strategy is to rewrite this as an exponent and then just figure out what those, what the exponent needs to be. Okay, let's look at this next one. So what this really means is log base e of e to the 10th. Here's our base, and that's equal to something. All right, so we want to take e to what power, and that's equal to e to the 10th. Well, our exponent obviously is 10 here. So to solve these, I'm rewriting this in the exponent form, and then I'm looking to see what is the exponent. Oops. All right, let's simplify these expressions. So log base 19 of 19 is equal to what? That better be 1, because 19 Okay, 19 to what power is equal to 19? It's 1. Okay, so same thing here. If there's just a log without a base, that is base 10. So log base 10 of 10 is equal to 1, right? Because 10 to the first power is equal to 10. And then we've got natural log of e is also equal to 1, because what natural log means is log base e. All right, so if we're taking log base e of e, that is equal to 1, because we have e to the 1 to the first power is equal to e. All right, so that is that's based on that second property there. All right, now let's look at when we have the log base 273 of 1. Okay, so that means 273 to what power is equal to 1? Well, 273, anything to the 0 power is equal to 1. So, all right, so here, if we have the base of 1/8, and we're saying, okay, take that to what power? And we're supposed to get that equal to 1 right here. Well, it has to be to the 0 power, so the exponent is 0. Now, I'm going to rewrite this again. So here's my base. 30 to what power is equal to this, that what we're taking the log of is 30 to the 10. And then you can just see, to make this equation true, that exponent has to be 10. Okay, so rewrite it as an exponent and then figure out what makes that equation true, which is 10. All right, here, if we have natural log of e to the negative 12th, that is going to be negative 12, because rewriting this, what natural log means is log base e, okay, and then we're taking log base e of e to the negative 1/12, and we're trying to figure out what's that equal to, okay, and then rewriting that is as an exponent. E to what power is equal to e to the negative 12th, and then the only way to make that equation true is if we have an exponent of 12. All right, so just rewrite it. If it's in log form, rewrite it as an exponent. If it's in exponent form, we can rewrite it as a log. Okay, so whatever I'm taking to a power, that's my base. So I would take log base 10 of what is equal to this exponent. Okay, so that's exponent is log 14, and then just remember, if there's no base, that is a 10. Okay, so log base 10 of what is log base 10? Well, that better be a 14 to make that equation true. Okay, so that needs to be 14 in there. Okay, and then likewise, same thing with this. This is my base, so log base 8 of what is equal to that exponent, okay? And the exponent is log base 8 of 5, okay? So, well, what do I have to take the log of to make both of these true? It better be a 5. So as we're working with these, if you rewrite your equation using the definition of logs, if it's in log form, rewrite it as an exponent. If it's in exponent form, rewrite it as a log. Okay, and then you figure out, how do I make my equation true? And you will be proving these properties of logs. And these you definitely need to know and understand why they work.